In this video, we will be going over the procedure of performing a TLC co-spot.
TLC, short for thin layer chromatography, is a process by which the polarities of different samples are compared, and a TLC co-spot is a method to directly compare the polarities of two samples by running the TLC procedure on both, and this is usually done to compare an unknown sample to a known one.
For a TLC co-spot, you will need a graduated cylinder filled with 10 milliliters of solvent, 2 vials, each with a small amount of a different sample in them, a capillary tube, a TLC plate, a 100 milliliter beaker or jar with lid, and a pencil.
Start by adding a small amount of the solvent from the cylinder into the vials with the different samples. Mix the contents of each vial until the sample is completely dissolved in each. Pour the remaining solvent still in the cylinder into the jar or beaker. Take note of the level that the solvent reaches in the jar. It should just cover the entire base of the jar but still have a relatively small amount of solvent total. Take the pencil and draw a straight baseline across the TLC plate near the bottom, but high enough that the baseline will be above the solvent level of the jar or beaker. On this baseline, mark 3 marks. A left mark for the first sample, a right mark for the second sample, and a middle mark where both samples will be placed. Take a capillary tube and use it to place a dot of each sample's solution on its respective 2 positions on the baseline. Now place the TLC plate in the jar or beaker, making sure that the baseline is originally above the line of the solvent. Now the solvent should begin to climb up the TLC plate, taking the samples up with it at their own speeds. Cover up the jar or beaker with a lid to speed along this process. Once the solvent has nearly reached the top of the TLC plate, mark this level with a horizontal line. Now, take the plate over to the UV lamp and circle the position of each sample. You can now measure the RF value of each sample, which is the distance from the baseline to the sample divided by the distance from the baseline to the final solvent line. The sample that reached farther up the plate will have a higher RF value and will be less polar.
The reason that the more polar sample will not travel as far is because it will have polar intermolecular attraction with the TLC plate. Polar intermolecular attraction is stronger than the nonpolar van der Waals attraction, which means that more polar samples will bond closer with the TLC plate than nonpolar ones, making the polar samples less susceptible to be swept away by the solvent. Therefore, the polar samples do not travel as far up the TLC plate as nonpolar ones do. In a similar way, polar solvents take a longer time to travel up the TLC plate than nonpolar solvents, while the samples in them travel at the same rate as before. Therefore, because the samples travel at the same rate while the polar solvent travels slower, the RF values for all samples will be greater in a polar solvent than in a nonpolar solvent.
This concludes our explanation with regards to TLC co-spotting. Thank you for listening.